Hello, Algebra 2. Here we are with Section 2 of 6.3. We got multipliers on the inside of our square roots now. Okay, our first problem here is just a recap of where we finished up yesterday with day 1 with the multipliers on the outside. We know that anything on the inside is going to move left and right, and it's going to be opposite. So we're actually going to be 1 to the right. On the outside is going to control up and down, and that's the same as what your brain would naturally think. So a minus 5 is going to move us down 5. And that's our start point. 1 to the right, 5 down. 1, 2, 3, 4, 5. Even though it's a nice point, we still want to label our starting point for our graph of the square roots. It's because it's super important into the second half of the problem. Okay? Now, normally, our nice points are over 1, up 1, because the square root of 1 is 1. So we go over 1, we go up 1. But we have a 3 times multiplier on the outside. And outside multipliers affect the y. So if we go over 1, up 1, but it's times 3, we're going to go up 3. 1, 2, 3. Okay, next nice spot is over 4, because that's a nice perfect square, and the square root of 4 is 2. So if we go over 4, usually we go up 2. But again, we have times 3 affecting our vertical. So instead of 2, we're going to go up 1, 2, 3. 2 times 3 is going to be 6. We're going to go up 3 times as much. 1, 2, 3, 4, 5, 6. Should be 1 above, right? Unless I miscounted this one. Okay. And really we just need our start point, and we need 2 more dots. We could probably get 3 more dots here, because the next perfect square over is 9. 9 over should take us all the way to the edge. The square root of 9 is 3, so normally we'd go up 3. But we have 3 times 3, so we're really going to go up 9. Okay, that was 6, so 7, 8, 9. And you can see that 4th dot in total, or the 3rd dot after the start, really gives us good direction here for the shape of our curve. Okay, and then our domain and range, very closely related to our start point. We're going up and to the right. So we're going right, so my x's are all going to be greater than or equal to 1. These are all going to be greater than or equal to, or less than or equal to, because the dot is solid, it is included. And we're going up, so my y values are increasing, my range, the y's are greater than or equal to -5. Okay, same exact problem. But now there's a 2 multiplier on the inside. There's a 2 multiplier on the inside, and that complicates things a bit. Okay, the easiest thing I can tell you is we're going to get our x by taking whatever's inside and setting that equal to 0 and solving. So we would add 1 over, and then we divide by 2. And the x-coordinate of our start point is a half. Okay? Positive 1/2. Our y-coordinate is still coming from that -5. So our starting point is going to be at 1/2, -5. Okay, and we're going to label that, number 1, because it's not a perfect point. Number 2, because it's the starting point, which is super important for when we do the domain and range. Okay, now the next part is even extra tricky. Because you saw up here when we were doing this, when we were able to just know we're going to go 1 over, 4 over, 9 over, and then you just had to worry about adjusting how much we're going up. That wasn't too bad to do mentally. Okay, now we're going to be adjusting the over number and the up number at the same time. That gets a little tricky. So I just write down the pattern. Okay, it's 1, 1, and then 4, 2, and then 9 and 3. I guess in my mind, that's just over 1 up 1, over 4 up 2, over 9 up 3. Okay, the outside number we know affects the y's. Let's go with a multiplication dot. Multiplication dot, because if we used an x there, I'm afraid we might get confused with like the variable x. And on the inside, okay, just like its opposite, like a -1 means to go 1 to the right, a times 2, we're actually going to divide all our x's by 2 in the pattern, okay? So what does this mean? We're going to go over a half and up 3. We're going to go over 2 and then up 6. And we're going to go over 9 divided by 2, 4.5. Sorry to switch from fractions to decimals. And up 9. Okay, so over a half, up 3. It's actually not too bad because we're starting at a half. So over a half puts me onto 1. Up 3, 1, 2, 3. Over 2, up 6. So we're 1, 2. So we're 2.5. And then up 6. 1, 2, 3, 4, 5, 6. All right, technically we just need a start point and 2 more. We can fit this one on there pretty good. Over 4.5 and up 9. 1, 2, 3, 4, and there's my half. Puts me on another whole x value. Up 9. 5, 6, 7, 8, 9. Okay, and we can graph away. We needed to label this one. It was over 2, so that's going to be 2.5 or 2.5, comma 1. The other 2 were perfect points. Okay, domain and range again. We're going up and to the right, so we're going to the right. And I told this to the kids in class. I can't think of a time in Algebra 2A when we would flip this over. I'm pretty sure we're all going to the right, 99%. So it's going to be x is greater than or equal to 1/2. And then for my range, we're going up. So y is going to be greater than or equal to -5. On our third one here, in the interest of saving time, let's see if we can find a good one. Let's do 2 more. We'll do 2 more. Let's do the negative one. Okay? A negative multiplier. All right, so again, step 1. What makes inside the square root equals 0? Okay, 4x minus 2 equals 0. 4x equals 2. X equals 1/2. So we're going to start at 1/2 and at 4. Positive half, 1, 2, 3, 4. We'll write it down. Okay, and now we're going to go, what is our pattern? Normally it's over 1 up 1, over 4 up 2, over 9 up 3. Okay, but for our y's, we're times by -2, and then this is going to be kind of yucky. Our x's, we're going to be dividing by 4. Okay, so 1 divided by 4, we're going to be going over 1/4, and then up, or down, -2, we're going to be going down 2. So if you want to put a -2 or a down arrow with a 2, okay, this one's not bad. 4 divided by 4 is 1. We'd be going over 1, and then down 4, 9/4, and then down 6. Okay, so if I'm looking at that, I'm already at 1/2. Okay, last time I was at 1/2, and then my overs were either whole numbers or half, so it worked out okay. If I'm at 1/2, and now I have to go over 4ths, that's not going to be very pretty. So I really want nice numbers, okay, or halves. 1 did not play well when dividing by a 4. 4 divided by 4 is pretty nice. It's a 1. So then at least this is still on a half, and I'm not doing other smaller fractions. Okay? Fourths and halves aren't terrible. Okay, but we prefer nice ones. And we need start point plus at least 2 other points. So we could definitely do that one. That's not bad. Okay, 9. What's the next perfect square? 16. Okay, the square root of 16 is 4. All right, so this one is actually not going to be bad. 16 divided by 4 would mean over 4, and then down 8. So then maybe we would use this one and this one. Okay? So from here, I'm going to go over 1, down 4, 1, 2, 3, 4. That's going to be 1.5, comma 0. And then use my other one here, over 4, 1, 2, 3, 4, down 8, 4, 5, 6, 7, 8. All right. And that is 4.5, negative 4. All right. Tough to see how we're going here. It almost looks straight down. If we did another one, we'd get a little bit flatter of a curve. It's going to take a while to get out there. So here's what we have. It's going to be steep and then down and to the right like this. Okay? Our domain and range, we're going to have, we're starting at a half, comma 4, so our domain, we're going to the right, so x's are greater than or equal to a half. And our range, we're at 4 and going down, so y's are less than or equal to 4. We'll try one more here with a fraction in the front. Let's go all the way down to the bottom. Again, step 1, what makes this equal 0? So we should be getting positive 2 for our x, negative 6 from that one for our y. So we're going to start at 2, negative 6. 1, 2, 3, 4, 5, 6. All right. Next, normally we have 1, 1. 4, 2, 9, 3. Okay. And we are, oh, look at this. Multiplying our y's by a half and dividing our x's by 2. So really same thing. So this is going to be over a half, up a half. Let's see what this one is. Over 2, up 1. Fractions here, 4.5, 1.5. Okay, and 0.5s aren't terrible, but if you want to avoid them, we can go to the next spot here. The square root of 16 is 4. Divide that by 2. We're going to go over 8 and up 2. So I'm going to use these two because I'm on a nice point. I'd like to stay that way. So if we go over 2 and up 1, and then over 8 and then up 2. It's pretty flat. All right, and there we go. Now another little cheater method for you. And sometimes it works and sometimes it doesn't. All right, you can check yourself with your calculator. If we type in 0.5 times the square root of 2x minus 4, arrow out. Make sure you're out from under the square root now. Minus 6. And we graph. Okay, we can see it's about the same. You can use trace to find some nice points if you want to push trace and double check. Like 2, enter. Yep, 2, negative 6, 3, enter. Not very pretty. 4. Okay, 4, negative 5. We had that one. All right, another really easy way to do that is second table. All right, we have all these errors up here because our graph starts here and it does not go backwards. So all these spaces back here is going to say error. Okay, so here we are. We had 2, negative 6, and now we're just looking for nice points. 4, comma, negative 5, we have it. And 10, negative 4, we got it. Okay, sometimes that works. Otherwise, sometimes you just get a bunch of decimals scrolling through there. Look what the next nice one is. You'd have to go all the way out here to 20, comma negative 3 to get the next nice one. Okay? If you do scroll out a ways, I'd always recommend coming back to putting 0 kind of in the middle, so the next time you do it, you don't get lost. All right. There it is. Thanks for watching. Good luck on the homework. Let me know if you have any questions.